Hey everybody, Bipingondane here, and let's be real for a second. Circuits. They're kinda like the magic behind, well, everything electronic. But if you're staring at a circuit diagram like it's written in some ancient alien language, trust me, you're not alone. That's why we're diving headfirst into this beginner's guide to reading circuit diagrams. Whether you're just starting out, or maybe you just need a little refresher, we're gonna break it all down in a way that even your grandma could understand. No more staring blankly at lines and squiggles. We're gonna make you fluent in circuit speak. So grab your soldering iron, put on your safety squints, always wear your safety squints, and let's get this show on the road. Alright, before we can build ourselves a time machine, or, just a simple LED circuit, we gotta know what we're looking at. Think of circuit symbols like the alphabet of electronics. You've got your resistors, looking all squiggly, representing their resistance to current flow. Then, there are capacitors like those two parallel lines, storing energy like tiny electrical reservoirs. And who could forget our good friend the diode, with its arrow pointing the way, only allowing current to flow in one direction. Master these basic symbols, and you're well on your way to deciphering any circuit diagram. Now that we've got a handle on our symbols, let's introduce the stars of the show, the actual components. Resistors, our squiggly friends, limit current flow, which is crucial for protecting other components. Capacitors, our energy-storing buddies, can smooth out voltage fluctuations, kind of like tiny electrical shock absorbers. And then there are transistors, those little electronic gatekeepers, able to amplify signals or switch current on and off. Knowing what each component does is like having the instruction manual to the circuit's inner workings. Okay, so you've got your symbols down, you know what each component does, but now it's time to talk about how it all comes together in a circuit diagram. Think of the layout like a roadmap for electrons to flow through. We'll follow the lines called traces, which represent the wires connecting everything. We'll see how components are arranged, either in series where the current flows through them one after another, or in parallel where the current splits between them. It's like connecting the dots, but instead of a pretty picture, we get a functioning circuit. Chapter 4. Power Up. Finding the source and ground. Every good circuit needs a starting point, and that's where our power supply comes in. It's like plugging in your phone charger. Gotta have that juice flowing. On a circuit diagram, the power source is usually marked with a plus symbol for positive voltage, and a minus symbol for, well, you guessed it, negative voltage. And just like your phone charger needs that third prong for grounding, circuits need a reference point with 0 voltage. That's our ground, often represented by a symbol that looks like a series of decreasing horizontal lines. Knowing where your power and ground are is like knowing where to plug in your circuit to bring it to life. Alright, we're getting into the nitty-gritty now. Each component in a circuit comes with specific values that determine how it behaves. Resistors, for example, are measured in ohms, represented by the Greek letter omega. Capacitors store energy and are measured in farads F, while inductors, which we haven't talked about yet, store energy in magnetic fields and are measured in henries H. These values are crucial because they determine how much resistance, capacitance, or inductance a component will actually have in the circuit. It's like fine-tuning your recipe for the perfect electronic dish. Now that we speak circuit lingo, let's talk about how signals move through our circuit. Think of it like following a path through the woods. We'll start at our power source, follow the traces, our paths, and see how the signal interacts with each component along the way. Does it get reduced by a resistor? Does it get stored temporarily in a capacitor? By understanding how to trace the signal path, we can understand how the entire circuit functions as a whole. It's like putting together a puzzle, but instead of a picture, we get a working electronic device. We've covered a ton of ground here, but like with any new skill, the key to mastering circuit diagrams is practice. Start with simple circuits, maybe a basic LED circuit, and break it down piece by piece. Identify the components, their values, the power and ground connections, and then try to follow the signal path. As you get more comfortable, you can move on to more complex circuits. And hey, if you get stuck, don't be afraid to ask for help. There's a whole community of electronics enthusiasts out there, myself included, who are always happy to lend a hand. Well, there you have it, folks. You've officially taken your first steps into the world of electronics. Remember, reading circuit diagrams is like learning a new language. It takes time, practice, and maybe a little head scratching along the way, but the rewards are well worth it. Being able to understand and build circuits opens up a universe of possibilities, from simple DIY projects to more complex electronics. So, keep experimenting, keep learning, and most importantly, keep having fun with it. Thanks for tuning in. Don't forget to like, subscribe, and smash that bell icon for more awesome tech content. Until next time, happy circuit building.